Hi, it's Mr. Kablan here again, and I'm here to present with the next lesson here for Chapter 7, dealing with angles. And today's lesson will be dealing with the relationship of the interior angles of quadrilateral and exterior angles of quadrilateral. So remember the last lesson we looked at the triangle, how the inside angles add up to 180 and the outside angles added up to 360. So today you're going to see something, again, same type of approach. The only difference is that we will be dealing with quadrilaterals. So let's get right to it here. All right, so again, let's start off with the definition of quadrilateral. So quadrilateral is any four-sided figure. And again, literally that's any four-sided figure. For example, if you name a rectangle, yep, that's a quadrilateral. You know, parallelogram, which we're going to see in today's lesson, that's going to be a quadrilateral. Okay, a square, yep, quadrilateral as well. So anything with four sides, again, those are quadrilaterals. All right, so let's first talk about the angle relationships between them, because that's the focus of today's lesson. Is that for both the inside and the outside angles, when you add them all up, okay, they in both cases they add up to 360. So when we're looking at the inside angles over here, in this case here, angle A, angle B, angle C, and angle D, when you add up those four angles, they add up to 360. And guess what? Okay, same thing applies to the ones on the outside. Okay, so as you know, the only number here is 360. And again, that deals with the relationship between interior and exterior angles. Okay, and one other thing I just want to point out here is that when you're looking at a parallelogram, I'm going to use this diagram as an example. If, for example, you're looking at angle A and angle W, so angle A and angle W, as you can see, form a straight line over here. So those two angles add up to 180. Okay, the same relationships also exist for B and X, C and Y, and D and Z. Okay, so as I said before, supplementary angles are everywhere. All right, so dealing with parallelograms, we're actually going to revisit something that we saw in the first lesson, is the fact that in a parallelogram, okay, opposite angles are opposite and diagonal angles are going to have the same measure as well. Okay, so another thing that's also with parallelograms is that the angles are also they form C patterns, okay, and you can solve for them in a similar fashion that you would supplementary angles as well. So, for example, if I take a look at angle A and B, okay, they would form a C pattern. Same thing with angle A and D, okay, and B and C, okay, as well as C and D. Okay, so if those angles would form the C patterns. Okay, and if you highlight those corners there, you would see that they do indeed form C patterns, just in different directions. All right, so as I said before, the one thing that we saw in the very first lesson in this chapter here is that the angles that are across from each other diagonally are going to be the same. So, for example, A and C will be the same, okay, as well as B and D. Okay, so we're going to see that again, and when we get to that question, we will perform two ways to do it, so you can see how you would approach it once you see the numbers in. All right, so let's first take a look at the inside angles first. And again, I'm going to present this in two ways, quote the long way and the short way. So just remember, when you're looking at quadrilaterals, all four angles inside the quadrilateral will add up to 360. So that's how we're going to do the long way first, is using the definition of that. So once we have that, you notice I've added the A, the 60, the 95, and the 100 degrees together, okay, to equal 360. So the next thing we want to do is we're going to group the like terms, okay, which are the three numbers in this case. And that gives me 255. And we're going to take the 255, move it to the other side, and then subtract it from 360. So angle A will have a measure of 105 degrees. Okay, so that's quote the long way to do it. Okay, the short way to do that is actually taking the exact same thing that we did in the previous example. Okay, just reduce it into two little tiny steps here. So what we're going to do there is add up the three angles, okay, and then subtract it from 360. Okay, and that will give us the exact same value here of 360 minus 255, and that'll give me 105 as well. Okay, now with a scientific calculator, you can actually do it from this first step here to give you the final answer here as well. Okay, just make sure that when you add up three angles that you put it in the brackets and get the calculator to do all the work for you. All right, so those are just the two ways you can do that particular problem. Okay, Now you're going to see that for the next example, when we're dealing with exterior angles, we're going to approach it the exact same way. That's why when it comes to quadrilaterals, knowing again, there's only one thing, 360 degrees applies to both the inside and outside angles here. So in this case here, we're going to set it up the long way first by adding up the four angles. So the x, the 85, the 60, and the 105 degrees, we're going to add them all up to give us 360. So you can see we're going to group the numbers together. Gives me 250. Take the 250 and then subtract it from 360. Okay, and the angle x will be 110 degrees. All right. In an alternate scenario here, okay, we're going to do it the short way, simply by adding up the three angles and then subtracting it from 360. So you can see here that either way you do it, you will still get the same answer, provided that you do the math correctly. All right, so those are just the basic calculations involving the interior and exterior angle measures of a quadrilateral. All right, so the next thing we're going to do now, we're just going to look at parallelograms, and we're going to again look at this in two different ways here. And the first way we're going to do this is we're just going to use the opposite vertices or the opposite corners of the parallelogram here. So what that means is basically what you have here is going to look across and diagonally to figure out the answer to the questions here. So starting off with angle x here. Okay, if you take a look at angle x, okay, angle x and 102 degrees, since they're directly across and diagonal to each other, those would be the same. Okay, and angle y would be the same as well. All right, so that's method one. Okay, method two, just remember that what you have here is that the x and the y will form C patterns with the numbers associated with it. So if you take a look at the angle x over here, angle x and 78 degrees, okay, they would form a C pattern. Okay, so you would do the same calculation as you would do supplementary angles. So you take the 78 degrees, subtract it from 180, okay, and that gives me 102 degrees. As you can see, the answers are exactly the same. And last but not least here, we have angle y over here, okay, and 102 degrees. They would also form the C pattern. And then from there, you take the 102 degrees, subtract the 180, subtract it from 180, and that would also give you the 78 degrees as required. All right. Okay, so as you can see, that was a very quick lesson there dealing with angle relationships with quadrilaterals. Okay, so until the next lesson, I will see you then.